Hello and warm welcome to all of you for 25th webinar of the knowledge series of our project, which is India EU ICT Standards Collaboration Project. As you know, the knowledge series is in partnership with TSDSI, which is the Indian Telecom Standards Body, and ETSI, which is the European Telecom Standards Body. And this webinar, which is the 25th webinar, is the second in series of what we are calling as standardization at 3GPP. And the title of the webinar today is Evolution of the 3GPP Core Network with 5G and the Support of Verticals. And to deliver this webinar, we have Mr. Lionel Moran, who is chair of 3GPP Core Network and Terminals uh, Technical Specification Group. So a warm welcome to you, Lionel.
Thank you.
So I can also say bonjour.
Bonjour, bonjour à tous.
Yeah. And just to share a bit detail about the profile of Mr. Lionel, since March 2019, Lionel is the chair of 3GPP Core Network and one of the three TSGs with radio access networks and service aspects responsible of the management and coordination of technical work in 3GPP. Before that, Lionel has been TSG CT Working Group 4 chair since July 2016, and after serving as vice chair from 2012 to 2016, and as Orange lead representative for about 20 years, he was an active member and a key contributor in the development of the IP-based core network. So a warm welcome again, Lionel, and as usual, for the 5G topics, we are fortunate to have Mr. A.K. Mittal, who is the advisor, network systems and technologies on behalf of TSDSI. And Mr. Mittal, as most of you know, is a seasoned professional in the domain of telecom. He started his career long back with 44 years of experience in the telecom industry. I don't think many people can say that they have that kind of experience, and he has been working in past with the Department of Telecom on topics like satellite communication, microwave, mobile network, switching systems, network management, licensing, regulation, standards, testing and certification, etc. And in his current role, as I said, he has been closely looking at the 3GPP work on behalf of TSDSI. So a warm welcome to you, Mr. Mittal.
Mr. Sachin.
Yeah, and with that, if I hand it over to you, Mr. Mittal, can you share the bit of context and maybe take it forward with Lionel?
Yeah, sure. Thank you, Sachin. And I will not take much time. I will just try to mention that we are fortunate to have Mr. Lionel here, an expert in this field. And you all know, most of you who are here, or maybe some people who are new, for their information, 3GPP is the global standards body for mobile networks standards. And I think about 700 companies are the members of this organization. And with that collaboration, we have been seeing every 1.5 or 2 years new releases and new features and evolution of technologies. He will explain in his presentation how 3GPP is structured and how it works, and then his role in the core networks and terminals. So the other two parts are services and radio. So what services and radio do is how to create interworking between the devices and the network and what services are required. But the main job of collating all that and delivering those services and managing those services and many other parts and interfacing with external networks which are of different types and evolving in various fields, and like non-3GPP networks. Now we will have non-terrestrial networks also. And they had really a challenge of, when it came to 5G, release 15, they had a challenge of maintaining the 4G core, upgrading it to 5G for dual connectivity, and also have new features and functions for 5G core alone. So I think it will be very interesting to know and understand how these things evolved and how the CT group and Mr. Lionel has played a role in this. And we will have a question. Kindly put your questions in the chat box. They will be taken up in the after the presentation, and those will be answered. So please, I hand over to Mr. Lionel for his presentation. Thank you.
Thank you for the introduction. So good afternoon, everyone. So in Paris, it is still the morning, but with different time zones, you're in the afternoon. So I think you had already a presentation from Georg Meyer, the chair of the ESA TSG. So what I would propose to do during this presentation, yeah, sorry. So here is the overview of the presentation that we will have today. So I will briefly introduce the 3GPP organization, how it works, with a focus on what we are doing in the core network and terminal TSG. And after that, I will go through some information regarding release 16. So I will explain what is a release from a 3GPP point of view. And I will explain also what was before release 16, that is the introduction of the new 5G radio access technology, and what we have done in release 16 and what is foreseen to be done after release 16. So at the end of this presentation, I think that we will have enough time for a Q&A session. So briefly, 3GPP. So you have a dedicated presentation that was, I think, presented last week by Georg. So you will have more information inside, but it's just for people that that were not attending this session to give you an overview of what is a 3GPP. So the 3GPP, so first of all, the name 3GPP means third generation project partnership. It was something created in '98. And the goal at this time was to coordinate a global standardization effort to be able to implement the new radio technology at this time that was a 3G radio access network, and so UMTS. And the idea was to create a project including different standards bodies from different regions of the world. So we have people from North America, from Europe, and from Asia. So you can see that TSGSI is part of this group of standardization bodies. And the idea is to make in common the resources to be able to work together on the creation of a set of specifications that will be common to all the regions. So 3GPP is a project where we are creating specification describing how the whole system should work, but the standard itself is created by the different standard bodies. So we're providing the set of specification to the standard bodies, and it is the role of the standard bodies to make them as a standard for the different regions. We are not working alone. We're also including what we call market representation partners. So it is people that are not standardization bodies, but are really important in the definition of the service requirements that mobile systems need to support. So, for example, I can quote GSMA, NGMN. We have also a dedicated group for emergency services, TTCA. Now we have new, what we call verticals, is industrial sectors that needs that need some requirement from the network just to be able to provide the service. So you have the automotive area, you have the industrial area, the health area. So this kind of partners are there, and all of them create what we call a PCG. You will see what it is after that. And obviously, we're not working alone. We have also a set of cooperation with external SDOs. So, for instance, ITU, IETF defining IP protocols and other area. And as it was said previously, today we have about 700 companies part of the 3GPP. Part means that you are a company that is first a member of one of the regional standard bodies. So you need first to be, for instance, a company member of a TSDSI, and through that you are able to participate to 3GPP. And what it means today, it's that we have about, it's really difficult to say, but we have more than 2,000 delegates in the different working groups, and it's cover about 45 countries today. And this is the actual number, and for the last decade, we see this number increased. So normally, the work is based on a regular face-to-face meeting. I said normally because with the COVID-19 outbreak that we have experienced and we are still experiencing today, we had to cancel the meetings and to move to an electronic format for the meeting. And in the meeting, it's really proactive, saying that if you want to see something happen in 3GPP, you need to provide a contribution. So it is not a kind of front office where people would say, I need this, and you will have other people doing the job for you. You have to be proactive, so you need to contribute actively to ensure that what you would like to see supported by the network will be done by 3GPP. And we are working in the consensus model, saying that we can agree on something only if all people in the room in 3GPP are okay with the principle. Say okay with the principle doesn't mean that everyone is in love with the proposal, but at least there is no one expressing serious concern about what was proposed. And we have a concept of release, and a release is that every 15 months, I would say, time to time, it could be 18 months or even more. But what we say is that we have a beginning of the work and we finish the work. We are finishing the work 15 months after. And after that, we will have a complete set of features. So we're able to provide every 15 months a complete set of features that can be used by the vendors to develop their solution, their products, and that can be used by operators to ensure that they know exactly what they will deploy in their network. So it's what we call a release. A release is just a set of features that is delivered to the public and to the vendors every 15 months. So the technical work in 3GPP is organized as it is highlighted here. So we have what we call the project coordination group, and the project coordination group include the regional standard bodies and the market representation partners. So it is a kind of let's say, board of 3GPP, but the real technical work is done in what we call the technical specification group. So we have three main areas. We have one for the radio access network, one, so on the left, sorry, on the left, one for the service and system aspects called SA, and the one in the middle is here CT, core network and terminals, and I am responsible of this TSG. So inside the TSG, you have the work is split between working groups, and each working group is responsible for a dedicated set of protocol functionalities and so on. So the work is spread across the working group, and we try to have a consistent set of functionality covered by one specific working group. For instance, if you take the working group run here, this one is responsible to define the set of service requirements, not only for SA, but for the whole 3GPP. So each time we need to check what are the new service requirements that we will need to support for the next release. We have to see what was the output of the work done in this group. And we have the same for all the working group. Yeah, I will say briefly that we have meetings all over the year. So the TSG is about 4 times a year. It's not about, it's exactly 4 times a year. And for the working group, it's depend on the group, but you can have 4 meetings a year, or you can have up to 8 meetings a year. So it will depend on the activity and the workload of the group. Just to understand how we are working, so a release is actually for a release. So when you count 15 months, you will have what we call the stage 1. That is the definition of the service requirements. So for the next release, we have to think about what needs to be supported in our network, and what are the new services that we will need to provide, and what are the additional functionalities that we need to add. So this is a stage 1, and once the work in stage 1 is completed, we have what we call the stage 2. So the stage 2 is to come from what have been defined in the service requirements area and try to see exactly what kind of evolution we need to have in our system. So the evolution could be in the architecture. We may have new security requirements. We may have new media to support, and so on. So this is defined at the stage 2 level, and the stage 2 level derived from service requirements is trying to derive functional requirements. As soon as we have the stage 2 completed, it is time for the stage 3. And the stage 3 is actually where the protocol is done, where the specification and provided to the vendors are done. And it is mainly the scope of area of CT. So CT is responsible for all the protocol aspects and coding aspects that need to be supported in the network. So include interfaces towards run access network, and also interfaces toward external networks like internet or other organization. And obviously all the interfaces and protocols that need to support inside the 3GPP system. What you can see is run is a little bit different because they are dealing with the radio access parts. They are managing the different stage 2 and stage 3 in a vertical way. So first of all, they are dealing with the physical layer, for instance, and above the physical layer, so for the radio access parts, they are building additional functionalities and protocol on top of this physical layer. So they have a standalone way to work, but they are following the same principle of stage 1, stage 2, and stage 3. Now, when we are talking about a release, this one will be reused later, but it's not to see the exact dates, because I will explain it after, but it's just to see that when we're talking about release, we're not working on one single release, and after that, we are starting a new one. Several releases are worked out in parallel, saying that when we're completing a given release, actually the work on the next release has already started. With the stage 1, for instance, and after that you will have the stage 2 and the stage 3. And when the stage 3 is completed, actually the work on the next release is still is already started. And in this way, we can do the work in parallel and in sequence, and people are able to work on one type of requirements, whereas other people are developing specific solution for the previous release. So we are not blocked at the end of a release with nothing. We have a continuous work during all the year and during all the time frame. About CT, so what we could say is that we kind of we are a factory. What we're providing, it's enablers that can be used to support all the functionality defined at the system level. So we're transforming service functional requirement into network enablers, into network solution, into network protocols. So when you are talking about protocol, it means signaling, it means user traffic, it means a lot of services provided by the system. So this key component are worked out by CT. And we can go through the responsibility of the supported by the group. So signaling plan, user and terminal mobility management, call session control, and so on. But the key message here is to understand that obviously to create a mobile system, you need a mobile interface, a radio interface. So this work is done by RAN. Obviously, we need to support services and so on, and the set of services is defined by SA. But just to be able to have a network working, you need to have all the signaling, all the interfaces put in place, and this is the role of a CT in that case. Now we're completing what we call the release 16, but the release 16 obviously come after the release 15. And the release 15 was a completely new area for us because it was the introduction of a new 5G system, a new radio interface, so 5G or NR, new radio, if you want to be exact. And I will concentrate my presentation right now on the impact at the city level. So it is a new radio interface, but you have different aspects. For instance, what we have done in the architecture today is to create what we call a distinct control plane. So this is above here, and the user plane. So typically the user plane, it's where the traffic goes from a terminal to another terminal or to another network. So it is here. So we are relying on this side on the new radio, and on this side we rely on the IP protocols just to be able to transport the user traffic. But all this user plane is controlled by the set of functionalities here, and this set of functionalities has been defined on what we call service-based architecture. So for the introduction of 5G, we have introduced a completely new core network, and it was a huge user change in the work that we were doing in the 5G, because before 5G, everything was inherited of what we have done still GSMS, I would say. So obviously, we're not using the same protocol, but the philosophy was the same. You have a set of nodes in the network, and you're just describing interfaces between nodes. So in 4G, everything was based on diameter, for instance, and the signaling plan for voice was SIP. And now what we have introduced here is a new way to interact different functions. So it's not about node, it's about functions supporting services. So this is why we call this architecture the service-based architecture, where, as I said, the notion of service replaces the notion of node, and any service in the network can discover another service and use a service. So it's a more flexible architecture, and this is also more appropriate when you want to virtualize your network. And you will see, but with the solution that we have adopted, this kind of architecture is intrinsically supporting the network exposure services to third parties. So what was a major achievement for CT? So for RAN, it's obviously the introduction of a new radio interface. But for CT, it was to provide what we call a flexible platform. So you should be able today to support virtualization, to have something that it is cloud friendly. We want to have something programmable, stateless, scalable, and we want to ease the introduction of a new service and feature. So the idea is not to have something where each time you need to introduce something, you need to work hard to be able to introduce a new feature, a new service. We want to, as I said, create an enabler that will ease the introduction of any new service in the future. So the main decision at the city level was to rely on what we call APIs, just to expose services offered by network functions, NF. So what it means is that today, instead of relying on diameter, as I said in the past, we are relying on HTTP. So we have a kind of a web-based interface, and HTTP2 is used as transport protocol. And we are following a principle for the design that is called REST, representational state transfers, that give us a set of guidelines that need to be supported when you are developing the interface. And it is really useful when you want to provide your work to a third party. So the third party could be a vendor, or it could be another organization, and so on, because you have a way to define your interface that will be understood by everyone. So this is something that we have adopted here, and it is something that is commonly used over internet or over IT. We have a specific way to describe the interface and how the interface is using. So it's what we call open API description. So when you read this document, you see what you are expecting as input and what it is expecting as output. So you have a complete description of the interface, but just using something that it is easy to handle in the text format. And we have a basic overload control mechanism, so that is a versioning mechanism. This one is really, so the standardized versioning mechanism is really useful. So it is something that we have developed in 3GPP, and it is really useful because we know that the network will evolve, and different set of function will support different set of services. So when you want to ensure that one given function supports the service that you would like to have and that will support a new feature, you can rely on this versioning mechanism to ensure that you will be able to interconnect with this function. And you will know also that you cannot discuss with another function because you have not the same level of functionality between them. Obviously, as it was said, when we are talking about release 15, it was not only 5G, and it was not only for CT limited to the service-based architecture definition. We need to maintain existing network, and this existing network today is mainly 4G. So we had first evolution of the 4G core network, and we have also the evolution of the 4G network to be able to support the new access radio. So it's what we call a non-standalone service or architecture. It's where you are using the new radio interface, but you are still relying on the 4G core network to be able to support the signaling and the traffic. IMS, so IP multimedia services or subsystem, was developed to support voice over IP services relying on SIP. And we have defined the interaction between the new core network and the old platform, IMS, just to be able to still support voice over IP over 5G. And talking about verticals, so for instance, here you can see that from release 15, we are able to support mobile communication system for railways. We have a standardized interface for machine-to-machine services. So you have third parties provider providing service machine-to-machine type communication, and they can rely on the core network just to be able to support some functionalities like location services, triggering of devices, and so on. And they are using a specific interface just to be able to interact with the core network and asking for specific services. And obviously, release after release, you will see that also in the next one. But release after release, we are enhancing what we have already. So, for instance, we are supporting specific mission critical services, what we call cellular IoT for Internet of Things, vehicle-to-vehicle communication, or vehicle-to anything or everything communication, and so on. And we need also to maintain the existing protocol specification. So you can see that when we're talking about a specific release, it's obviously about what is new in this release, but we need also to maintain what was there and to enhance what was previously defined by CT and 3GPP. Now for release 16, I would say that from a CT point of view, as I said, the real new paradigm was for release 15, and for release 16, we are building on what we have defined in release 15. So it is easier, for instance, to introduce new services. So we are introducing new services. So it means defining new APIs or defining new functionalities that will be supported by the existing APIs. So for instance, we can quote a steering of roaming that will be introduced today. So a new functionality will be introduced in the network. As I said, location services will be also introduced. So it was there, but it was relying up to now on the 4G core network capabilities. And we will introduce the same kind of services inside the 5G. So it means that for this type of services, you don't have to rely on your existing 4G network, and you can go directly to the 5G network. So the goal, it's first to ensure that the complete set of services supported by 4G will be supported in 5G, and be able also to add extra services on top when possible. So at the city level, we have worked on a solution that will provide a solution to have a stateless or dataless function. It means that you will have your function in your network, your piece of software in your network, but all the data and so on will be stored in a remote location, and you are using a dedicated API just to be able to store and maintain what we call dynamic state data. So it means that you may deploy different type of services in your network, but they will all share the same set of data, and it will ease the development of solutions for high availability or redundancy. We have defined the specific interfaces for the interworking of user data. So when you have your 4G and your 5G network, obviously you will have a client that will be in the same time a 4G client and a 5G client, and you need a way to maintain consistently the set of data in 4G and the set of data in 5G. So we have created a specific interface between what we call the HSS, that is the main repository in the 4G network. So the main repository with the subscriber data, and the equivalent in 5G is called the UDR. So we have created a specific API between those entities. Something also important, it's so it's not a fancy feature, but it's something really important at the protocol level. It's everything regarding load and overload control mechanism. So it's a way to ensure that your system will never go to an overload situation, or will have a way to control and to control overload situation, and to estimate the load on your network, just to be able to prevent any blocking situation. And for instance, to be able to move from one entity to another entity if you see that you have a risk of overload. So this was defined in the scope of the release 16, in addition of what we had already in release 15. Yes, we have a IMS integration, a better IMS integration with new APIs that can be used by the IMS system. And you will see that this is something, it's an ongoing effort, because it will be also done in release 17. And we have introduced the capability for voice call continuity, saying that you are able to have your call moving from the 5G network to the 4G network, without a disruption. And for the release 16, it was also a key challenge for us, because so usually the main requirements are coming from 3GPP. So they are defined directly by 3GPP members at the stage 1 and supporting the stage 2, and we are doing the protocol specification in the stage 3. But now we have more and more requirements coming from verticals. So as I said, it's industrial, it's coming from the industry. It's a specific type of requirements that need to be supported by a core network, just for them to be able to provide their services to the end user. So if you think about IoT, for instance, you have a nice set of IoT functionalities that you would like to be supported by your client, and you want to rely on the mobile network just to be able to support the communication between the IoT clients and the service platform. So to do that, we need to have clear interfaces with these verticals, and we need also to support a specific set of functionality inside the core network. So it is something that we have done in release 16. Obviously, it was not totally new. We have some features already supported in 4G, but in 5G, we can see that there is a kind of acceleration of this kind of a new requirement supported by the core network. So you have everything regarding network automation, for instance, that is really important for industry, what we call Industry 4.0. Time-sensitive communication, it's where you really need to ensure that you have all the entities are in sync in a local network, for instance. And it is something that was not supported so far, and it is now supported in Release 16. And something done by SS6 that is called the Service Enabler Architecture layer. So SS6 is responsible to define the service requirements for interaction with the verticals, but obviously when you have defined the service requirement, you need to have the protocol specification, and it is something that was done in Release 16. So this layer is a kind of interface, dedicated functional interface between the 3GPP system and the verticals. So through this interface, you are able to receive specific requests from the vertical and to support this and to fulfill this request using network capabilities. Cellular IoT is now, so it was based on 3G and 4G, and now you have the same on 5G. So you are supporting the new radio interface for that. Advanced services for vehicle to everything communication using 5G. And as I said, release after release, we need to maintain and to enhance the existing protocol. So we have enhancements for mission critical services, public warning system, future Huawei mobile communication system, and so on. And obviously, this slides and the set of slides is not exhaustive. We are doing more than that, but I could spend the whole day on trying to explain exactly what we are doing. Just to show you what we have done, you can see the workload. So from a city point of view, when the stage 3 work is starting, it's slow because we are still waiting for the output of the stage 2. As soon as the stage 2 is completed, you can see that you have an increased number of contributions just to be able to fulfill the service requirements. And after that, for a given release, there is you can see that you have a lower number because here at this stage, everything is almost completed. So after that, it's more correction of what we have already specified. And at the same time, you have a kind of a pump up here of the workload for the new release. And for release 17, it will be exactly the same. You can see a small difference here in the number of contribution compared to the number of contribution for release 15. There is two reasons for that. It's because, first of all, it was a completely new system to develop in release 15, whereas in release 16, we are working on, we are building up the capabilities that we have already introduced in release 15. So it's more or less enhancement of what we have already specified. And the second issue that we have to face this year was the COVID-19 outbreak. And as I said, all the face-to-face meetings were canceled. So since January. So the work was done, and actually we were really surprised that it was, I would say, so well. But we have to admit that it is less efficient than face-to-face meeting, because obviously you have the contribution that we can present and so on in a face-to-face meeting, but you have also all the offline discussion between delegates, just to be able to have a clear consensus of what needs to be done in a specific working group. And all these offline discussion are not so easy to set up when you are remotely attending a meeting. So it is less efficient. So I hope that for the 3GPP sickness, we will be able to resume as soon as possible the face-to-face meeting, but till the end of the year today, it is decided to go on with electronic meeting only. And but if the situation is getting better, we can try to resume at the end of the year or at the beginning of the next year. And what next? So next, from a release perspective, it will be the release 17. So the release 16 was concluded, so it will be completed this month, at the end of this month. So At the end of this month, we will call this release frozen, saying that release 16 will be frozen means that it will not be possible to add extra feature, new feature, and so on. So it is very important because at this point of time, vendors are confident on the fact that they will define something that will that they will implement something that will not change or not change so much. And so we're completing now, and for stage 3 point of view, it means that we will be able to start the work on the release 17. Here you can see that there is some gap, but actually it is normal because at this stage we will agree on what to do and we will start the work here. So this is something that will be start in the next quarter. So I was talking about stage 3. So if you want to have a clear, no, not a clear, some highlights on what will be done in release 17. So the content, the functional content or the set of features defined for release 17 is known. It will be difficult to introduce additional features, but we have, I think, a consistent set of features to support for release 17. Excuse me. And we will have enhancement of existing functionality like slicing. I will not go into the details, but it's something that was introduced with the release 15, and it's important to support. It's a way to define, using the same service platform, it's a way to define the distinct network paths for dedicated services. We have everything regarding edge computing that will be added. We will have evolution of the network automation, network orchestration, and so on, IoT, location services, enhancement, and the support of drones, for instance. That was already introduced in release 14, in release 15, and will be enhanced for release 17. But if you are talking about new feature, we will have what we call proximity services, is a way to for devices to discuss inside the radio access network. So you have a dedicated communication, kind of a peer-to-peer communication or device-to-device communication between UE, relying on functionality provided by the core network. We will have a way also to support multicast and broadcast 5G communication. That was already part of the 5G, but the introduction was delayed, and it was decided to put these functionalities within 17. One key part will be the introduction of the satellites in the architecture. So the satellites, so we will create a dedicated specification for the introduction of the satellites. We have more requirements coming from industrial IoT and the support of 5G media and virtual reality. So these features are from so it is defined for the 3GPP systems, and obviously at the city level we will contribute to either the enhancement of the existing services or the introduction of the new feature. But in city you will have also specific studies. So for instance, the evaluation of the support of a new version of HTTP, so-called HTTP 3. It was something that was started in the previous release, but the conclusion will be taken for this release. So for this release, at the end of the study, we will be able to know if we go for a new transport in the control plane or not. And you have a dedicated studies that will be done only in CT, for instance, the support of multimedia priority services. Before that, it was only voice, and now we will have to have a multimedia type of communication, so data, video, and so on. A better integration of the voice over IP platform, so IMS, inside 5G. And so, for instance, as I said, it was something already started in release 15 and even in release 16, but it is not possible to introduce everything at the same time. When there is too much work to support, what we are doing is just to delay a little bit, so to select a sub number of feature to introduce for one release and to put the other set of feature for the next release. And obviously protocol enhancement for the existing one. And I will conclude my presentation right now. So I know that it was fast. It was very, so there is a lot of contents, not so much detail, but I think it's not the proper pace for a technical discussion on these aspects. The goal was just to highlight the fact that CT was first one of the group defining the specification in 3GPP, and we are doing a lot of things, and it's something I think that we are welcoming new contributors and so on, and it's where we need some people to be really active, because as you can see, there is a lot of things to do in at the CT level. And that concludes my presentation. Thank you for your attention. Any question now?
Yeah, thank you, Lionel. We have some questions. I will read out one by one. So the first question is, what is the nature of cooperation with external SDOs or forums like IEEE, IETF, TM Forum, liaisons, joint working groups, etc., or at a higher requirement level? So this is the question.
Yeah. In 3GPP, we're defining the mobile system as a whole, so it's a global organization, but we're not defining all the solutions that are needed to be able to support the set of requirements for mobile systems. So for instance, if you take IP protocols are not defined by 3GPP, they are defined by IETF. So if we have a special requirement regarding an existing IP protocol, we're asking IETF for guidance just to ensure that what we would like to see supported by the protocol will be supported by the standard version, and the standard version will be developed by IETF. We have the same kind of relation with other SDOs. For ITU, for instance, ITU is the one responsible to give a stamp on what we call a new generation network, new generation radio access technology. So what we're doing is to define exactly what we are doing in 3GPP, but we are sending the set of specification to ITU just to ensure that this will give the stamp for the new 5G radio, and in that case, people will be able to implement to deploy the new access technology in their network. So this is this kind of coordination that we have with external bodies.
Thanks. Now this second question is release 15 functionality for railways enabled end-to-end, including RAN? Also, is this enabled in NR, NSA, or SA mode also?
So I'm not aware of all the functionality supported in this area. The thing that I know is that when it was introduced, it was for 4G, and because it was what the radio available there. But it is also now also used for 5G, and the idea is just to be able to have a kind of local network deployed inside a train, and to have a connection between the train and the network. So we're covering both. For more information on this, you can send me a dedicated question if needed, but you have to check what is available on the 3GPP website on this.
Yeah, that's right. Thanks. Now we have another question is release 16 CIoT. I mean, he's talking cellular IoT for 5G. Does it mean 5G NR in NSA or SA mode can fully substitute NB-IoT?
Yes, it is a goal. As I said, before that, cellular IoT was only relying on 3G and 4G technologies, and the goal is to support the same kind of services on 5G. Okay. So the devices will be connected to the core network using 5G.
Right. We have now next question. How does the release 16 service enabler architecture interact with 1M2M?
So before the introduction of this specific layer, each time we need to interwork with a dedicated third party, like one end-to-end. We were creating a specific interface, so to interact with platform provided by one end-to-end, for instance. Now with this service layer architecture, the idea is to have something that will be generic to any platform. And so the key aspect will be to develop a set of functionalities that can be reused by a lot of third parties, and it will ease the adoption of this interface by the third parties. Otherwise, each time a new party, a third party will come and ask for something, if we have to develop something, it will take time, and it is not something, it would be unfortunate to wait and to waste of time before having this functionality supported. So the idea is to create this generic interface, and obviously the generic interface provides a set of functionalities, and not all the functionality will be supported by all the third parties, but at least you have this set of functionalities that will be there, and it's kind of a toolkit that can be used by other parties, including one M2M, just to be able to interact with the network and to support services provided by the core network.
Okay, now I have another question is the release 16 ASN1 has been frozen? Is frozen?
It will be frozen at the next plenary. So the next plenary will be end of June, beginning of July. So it's a week. And at the end of the week, the ASN1 will be frozen. The goal is to freeze the release 16 at the end of June. And it will mean that first, it is not possible to include any new feature at the functional level, but also it will mean that the ASN1 is frozen.
Right. I think there are a lot of people, as I understand, had a feeling that because the release 16 freezing has been postponed by 3 months, whether ASN1 also has been impacted. Probably that is where
Okay.
from this question may be coming. Yeah.
Yeah, I can comment this. What we have decided to postpone the freeze of the stage 3. So the stage 3 is all the specification defining the protocol, as I said. So this was postponed of 3 months. So normally we were supposed to close the work in March, and it was decided to postpone it to June. But we have decided at the same time to not change the freezing date for the ASN1. So this date will not change. So it means that the release will be frozen in June this year.
Right. Now we have another question. Any reference YAML or XSD files defined for core interfaces?
UML and
it says, I also don't understand YAML. Any reference YAML or XSD files defined for core interfaces?
I'm not sure to get this question, but yeah, so I will not be able to answer. So
Okay.
except if you, yeah.
Yeah, so I think we can request the person to put his question again. It is not coming out very clearly. So we go to the next question. Next question is, can independent research group or individual join 3GPP and contribute in standards?
No. What you have to be, it's a 3GPP member, and to become a 3GPP member, you need to be part of one of the regional standardization bodies. So it is possible to be even a university or whatever, or a research group, but you need first to be a member of one of the standard organizations. So for India, it would be TSDSI. And you need to be first part of this, and based on that, you are able to contribute to 3GPP. I would say that anyone could contribute to the 3GPP effort, but you need to be part of one of the regional standardization body.
Right. I just want to add that if the person who is seeking this question. If he is in India, then they can contact TSDSI and they can guide further how to participate in 3GPP through TSDSI. So next question I have is, any work going on for rural broadband connectivity with focus on layer 2, layer 3?
No, normally it's not. It's one of the aspects where 3GPP is not normally relevant for this kind of work. So usually this kind of work will be done in an external body, and we will just ask for specific requirements there. For instance, we have a dedicated coordination with a broadband forum just to be able to support this kind of interaction with broadband access network. And but 3GPP is not intended for that.
Right.
Next
is
on this, yeah. Just to complete,
yes, please.
on this aspect, the only part where we are relevant is for the radio access part.
Right. Now we have that question of YAML has come again. It says, any reference YAML or XSD files defined for core interfaces, interface schema files.
Okay, but this was, so if I'm correct, so UML and schema, you said, right?
Yeah, it says interface schema files, and the interfaces reference files are YAML or XSD.
Yeah, exactly. So this was the case, for instance, for IMS. It was described like this, but because we have moved to HTTP, the new way to describe the different interfaces is to rely on what we call Open API. And with Open API, we are using a specific way to describe, as I said, what it is required as input and what it is expected as output. And it is a way now the interfaces are described. It was UML and XSD schema were more relevant when it was diameter, for instance, and this kind of stuff. But it's still used in 4G, but not anymore in 5G. So I hope that I answered to the question, but if it is related to the UML model and so on, it was more related to what we had in the past. They are still relevant there, but they are not anymore, they are maintained, but there is not so much enhancement on top of this.
Okay, I think this was the last question from the audience. I have one question. We have 2 more minutes, so I take liberty of asking one question at least. Is that now 3GPP is working for non-terrestrial networks connectivity, especially the satellite communication networks. So
Yes.
From your group side, do you see what kind of challenges do you see for serving satellite-based connectivity? Backhaul is one, another is satellite becoming a part of the 5G network.
I think that's it's something that we have tried to investigate a little bit at the city level, but it's quite difficult because it will really depend on the type of architecture that will be developed by SA2 on this area. So first of all, you will have impact obviously in the RAN specification, but at the city level, it will depend if we have to create new interfaces to be able to support the new type of, let's say, new type of access network or new type of local networks. If we want to develop new interfaces or just to reuse existing ones. So it will depend exactly on the set of functionalities that will be defined by SA2. So it's why on this one, it's not time to time we try to do the work in advance just to be able to have some studies to see what could happen. But on this area, we are mainly dependent on the output of the stage 2, and one specific group in stage 2, it will be SA2.
Yeah, thanks, Lionel, and thanks for covering the subject in all dimensions and providing knowledge in a limited time of how we evolved to release 15 and then 16 and what are the future plans. So I hope that the audience has benefited a lot. Thank you very much. And I now hand over to Mr. Sachin Gaur for the concluding remarks.
Yeah, thank you, Mr. Mithil, and thank you, Lionel, for making this great presentation. And if you are okay with this, can we share your presentation with the attendees?
Yeah, obviously you can, yes.
Yeah,
And
because I will.
at the end of the presentation, you have my contact address, so do not hesitate to send information. I will not be able to answer to all the questions, but if you have key information that you would like to have or some clarification that you would like to receive, do not hesitate.
Yeah. So I think, Lionel, this was a great presentation, as I said, and you are also agreeing to share your presentation. We have recorded this webinar and we put it on the YouTube channel of our project. So it will be available for a future reference for people who are interested. So we believe that with your support, we are able to make 3GPP more accessible for people. And in general, I believe, Mr. Mittal, maybe just a quick comment from you. The kind of question that came, I think, which was the very first question about 3GPP's interaction with other SDOs or other bodies. I was just wondering, maybe once we have the webinar series completed in terms of all the three working groups, maybe we could also, maybe it might be a bold idea, Lionel, but could we organize with all the three chairs, some kind of ask me anything, if you know Emma, and that might
Kind of panel discussion session.
Yeah, because here in this part of the world, I think a lot of people want to contribute to 3GPP, and there are certain topics, wherein so far they have not been able to contribute. I think rural telecom is one such topic, and your support from the 3GPP side might enable a more accessible approach in including and making the discussion more inclusive.
Actually, I can comment on this a little bit. Georg Balash and myself are doing a lot on this, trying to open the door to more delegates and try to explain how 3GPP work and so on. We have a dedicated presentation for that. That is a newcomer session that is usually done before the plenary. It's something that could be also set up, I think, for a dedicated Q&A session with others. Yeah, it was my point. Sorry for that.
Yeah, I think that such a session was organized on 16th of June, if I'm not wrong.
Yeah.
And I think some people must have participated, but it was, as you know, only for the IMs. So how do we, take it to the people who are not yet part of 3GPP? And maybe we will follow up with you for as Mr. Mittal said, that having all the three chairs in a panel discussion, and then maybe enabling a more open discussion, not with a fixed agenda, but answering questions as they come. So what do you think about it, Mr. Mittal? Is that
Yeah, I think structurally that looks good, but we can work out more details about it in consultation with the chairs.
Sure. So I think without further any elongation of this session, we are grateful to you, Lionel, again. Thank you for taking out time for us, and we are also grateful to all the participants for joining us and creating this conversation. And last but not the least, Mr. Mittal, also thank you for your kind moderation.
Pleasure, and thank you, and good day. Good day, everyone.
Good day, thank you. Thank you for the invitation. It was great. Thank you.
Thank you.
Bye-bye.